Hello, class. Welcome back. This week we're talking about batteries. Batteries, their construction, their function, their diagnosis, and their service. But today we're going to cover the construction aspect and how they work and what's inside them and that kind of stuff. What's going to come next week is going to be the service part. I'm going to get permission to go down to the lab and do some video, and we'll go through all that kind of stuff. So let's talk about what they are, why they are so heavy, what's inside, and what happens when they go dead. Right? So the functions of a battery: operate the electrical devices for the engine during cranking and starting. Right? Once we start, our alternator plays a role, but until that happens, we need something to take care of things until that happens. Right? We supply electrical power to the vehicle accessories when the engine's not running. Once again, the alternator will supply us stuff, but when the car's not running, how do we operate stuff? It's like the chicken and the egg. What comes first? And it furnishes current for a limited time whenever the electrical demands exceed charging system output. So you have an alternator on your car, and it's putting out 80 amps, and all of a sudden, you get an immense load. I don't know, you step on the brakes while putting on the windshield wipers and touching the rear window defogger at the same time while turning your stereo up really loud and the bass hits and the amp hits, and you tax that electrical system crazily, and the battery will say, hey, I'll help you, alternator, and it'll jump in and add a little bit more for those moments. It acts as a voltage stabilizer for the entire automotive electrical system. If we didn't have a battery, you'd see voltage fluctuations all over the place. You'd sit down and put your turn signal on, and your dome lights would go crazy, and you'd step on the brakes and your radio would cut off. This acts like a big shock absorber for the whole system, and it kind of numbs out the effects of smaller items in the circuit that are causing stuff. Stores energy for extended periods of time, hopefully. And the battery must be in good condition to test the electrical charging and starting systems. That's the key thing that you need to keep in mind. You cannot test a charging system or a starting system and expect it to be performing properly unless that battery is in good condition. So a battery test must begin before you look at anything wrong with anything else. Same thing goes with just checking stuff on a car. You're using a test light or a voltmeter. What happens if you only show 10 volts? Maybe it's because the battery you're connected to is 10 volts. There might not be anything wrong with the circuits in the car. So that battery must be in good shape before you do anything else. Right? In a conventional battery, right, we have positive plates. We have negative plates. What happens if the positive plate touches the negative plate? Fire. That's what happens. So we have separators in between them. Right? The plates need to be stored someplace. Otherwise, you just have this block of stuff that you can't do anything with. So we have to have a case to have it in. We have to make sure these plates don't jump all over the place and move out of spot. So we have to have some straps that hold them in place. And then we have our battery acid or electrolyte that it swims in. Therefore, this whole thing is bathed in liquid. And then you need a way to connect into the power that's inside that, and we'll have terminals. So if you look here, you'll see here's your positive plate. All those plates are connected to this tab. And the negative plates are all connected to this tab. And in between is our separators. Right? Usually they're made out of cardboard or something like that, just to prevent these things from touching each other.
As good as dead without the electric energy from the battery. Not only does a car battery generate enough juice to start the motor, it actually makes its own when the motor runs. That's because this plain-looking box accomplishes two diametrically opposed functions using exactly the same ingredients. It generates electricity and it accumulates electricity. The battery manages this incredible feat by exploiting reversible chemical reactions. Okay, so how does it work? A car battery has a positive and a negative terminal. They're connected to the car and send a flow of electrons to power the wipers, headlights, radio, air conditioning, and most importantly, the engine starter. Inside the battery are 6 small energy-producing units called cells. Each cell has 2 sets of electrodes. They're made of 8 overlapping metallic plates, for a total of 16 per cell. Together, the plates form a compact grid. The bigger the grid's overall surface, the more power it generates. The positive grid, covered in lead oxide, carries electrons in. The negative grid, covered in lead, releases electrons. The plates soak in a chemical bath. 65% water, 35% sulfuric acid. Volatile stuff. If you're not careful, a drop of it will leak through your clothes and burn off your skin. But the key to the car battery is all those powerful chemicals reacting with each other inside the cells. Reactions repeated as the battery drains. The bath of water and sulfuric acid acts as an electrolyte, a substance that conducts electricity. As the battery discharges or unloads electricity, the acid bath reacts to the chemicals on the plates. The lead covering one cell grid and the lead oxide covering the other. Dipping them in the electrolyte bath releases particles called electrons. When they start racing in the grids, they create electricity. As the electrons race from the positive grid in the first cell and out the negative grid, they produce 2 volts of electricity.
2.1.
The lead and lead oxide covering the electrodes have been chemically transformed. And when the electrons from the first cell zoom into the second cell, they pick up another 2 volts.
2.1.
Of 4.
Point
By the time the
2.
electrons charge out of the 6th cell, they have a combined voltage of 12.
0.6.
That's a fully loaded car battery with enough juice to power the starter and crank the engine. Once you've squeezed out all the juice to start the motor, the fuel system takes over and keeps the motor running. The car's alternator takes over the rest of the electrical chores. Time for the battery to juice itself back up. It recharges by reversing the chemical reactions. The electrons coming from the car's alternator now enter the battery through the negative grid of the cells and come out the positive side. The chemicals on the grids go back to normal, and the battery is recharged and ready to put out another 12 volts of electricity.
12.6.
That is, unless you happen to leave the car lights on overnight. In that case, the chemical reactions move in one direction, draining the battery, which never gets a chance to recharge itself. The inevitable result is a dead battery.